Hello, my name is Eddie and welcome to my YouTube channel. The purpose of this channel is to try and discuss some common beliefs and misbeliefs about health and medicine, and I'm going to try to break it down in layman's terms using real scientific evidence. Now, personally, I have done a little bit of research. I have one publication and a couple of conference presentations, and I am currently a medical student. And I'm not going to disclose any more information than that because I want to protect my own privacy. So, that aside, let's get into the first topic that I'm going to talk about, which is veganism. A lot of kids these days, they want to build muscle and they want to get jacked and they want to have big pecs, big chests, big biceps, big legs, big booties, big abs, big head. I got a big head, and they want to know whether it's possible to do all that while eating a vegan diet. And that's a large debate that's currently on the YouTubes these days that I see, anyways. So that's what I'm going to talk about today. Some of the arguments that I've seen vegan advocates promoting: one, protein in animal products cause an increased risk of cancer. 2, cells in your body run on carbohydrates and therefore we need to eat higher carbohydrates. And 3, and this isn't actually a point that they're making, this is a point that I'm making. A lot of these people like to cite research studies, and I have a little bit of an issue with the way they cite studies. So let's start with that first. So, in terms of research studies, what people need to understand is that research show correlation, especially when it comes to the research that are involved in clinical, these clinical studies. They most of the time show some sort of correlation, not a causation. And in order for a research study to be substantial, to hold weight, they have to have usually 2 characteristics, right? They have to be repeatable over and over again. And when I say over and over again, I don't mean once or twice, I mean hundreds of thousands of times. And you need a long period of follow-up. So when I'm talking long period, I'm talking about 5, 10, 15 years. And lastly, you need a large cohort of people because everybody is different. This everyone knows. We are all different. I'm different, you're different, he's different, she's different, it's different. Everyone's different. So we need a large cohort, followed through a long span of time, and the research. 3 things that we need to be looking out for when it comes to research. And we need to understand that research studies are simply used as a guidance, and you can't really take them as fact. And the example that I want to give is one of the largest studies out there looking at heart disease, and that's called the Framingham Heart Study. You can Google this, Framingham Heart Study. I'll even link it in the description below. In the Framingham study, what they did was they had a cohort of over 5,000 participants in a small town called Framingham, and they'd followed these people up for over 50 years. They've been doing this study since 1948, and their data has been repeated over and over and over again. And it's only because of those 3 facts that the Framingham study is considered one of the largest and most reputable studies when it comes to cardiovascular risk factors. So things like smoking is bad for your heart, things like high blood pressure, those are all things that came out of the Framingham Heart Study. And the reason why that's usable, because of the large number of cohorts and the long period of follow-up and the repeatability. Now, because most studies cannot be as long as the Framingham Heart Study, what people should be looking for when they are doing research, especially clinical research, is they should be looking at meta-analyses and systems reviews, right? So meta-analyses and systemic reviews. Those are kind of the 2 things that you want to look for because they combine a whole bunch of different studies together, and it mimics having a large population, because when you take 17 small studies and you put them together, the population is pretty big. And it mimics a long span because you can take studies ranging from whatever date you want. And it's repeatable because you're taking many studies that support your hypotheses or refute it, depending on what your results are. So that's my issue with research. Second thing, with cancer risk of meat. So The thing with cancer is that it's not a disease. Cancer is actually a group of disorders that are characterized by a dysregulation of growth. That's a textbook definition of cancer. Now, you can link the textbook down in the description. It's a medical textbook. And the way that most cancers work is that there's a two-hit hypothesis. One is that you need some kind of a mutation in your genes that you acquire from your parents. And this mutation is usually silent until one day you're walking down the street, well, not walking down the street, but you accumulate another mutation that all of a sudden activates the first mutation, and then your cells start going crazy and they start growing and dividing abnormally. And that's called the two-hit hypothesis of cancer. And the thing with that is every different subtype of cancer, because remember, cancer is not a disease, it's a category, it's a description. It all have different gene mutations and different risk factors and different ways that it comes about. That's called its pathogenesis. It has different ways in which it comes about. So you can't say that meat is an increased risk of cancer if you don't specify what kind of cancer. And in regards to whether there are correlations between meat and increased risk of cancer, I have done a bit of research and I have pulled some meta-analyses, which systemic reviews, which I will actually link. And I found that yes, there are some studies that show an increased risk of red meat with certain types of cancer. There are also studies which show no correlation. And there are studies which show that white meat, so that's chicken and fish, also actually has a decreased risk of certain types of cancer. Now, when something is this polarized, when there are scientific studies being done that are showing complete opposite things, the conclusion that I want to draw is that there is no definitive answer. And this is a lot of the thing. This is a trend in nutrition, is that a lot of the times there is no definitive answer for a question. And this is why most people advocate eating a well-balanced, varied diet. And this is something I'm going to touch on very soon, because a lot of things don't have definitive answers. So in conclusion, does meat increase the risk of cancer? I don't know. Possibly, but I don't know. Now let's move on to our next point. Next point. Cells use carbohydrates as energy, therefore you should be eating more energy. Now let's go back to our basics again. Your body, every living being, is made of 4 primary components: carbohydrates, proteins, lipids, aka fat, and nucleotides. And you can associate that with, use the analogy of a car to represent this, right? So carbohydrate, that's your gasoline. Protein, that's your frame, right? Your wheels, your axes, your body of the car. Lipids, they act as your seat cushions and your windows, things that keep you comfy in the car. Nucleotides, that's your instruction manual, your blueprint of the car. And those are the 4 main components of what makes every living being function. And notice that protein is one of them, because every cell in your body, every time the cells in your body does anything, any cell in your body, whether it's muscle or skin or bone or eyes or tongue, any cell in your body, when it functions, it uses a protein to function. And so yes, you need to eat protein in order for your body to function. That is a necessity. Because protein is essential for bodily function, and because we don't know whether there's an increased risk or not, eating a diet which is rich in protein as well as carbohydrates as well as lipids is essential for life. Now, we don't have to eat nucleotides because our body actively, nucleotides are a blueprint. We don't need more blueprint, right? But we do need protein, we do need fat, and we do need carbohydrates. Meat products, whether you like it or not, is the most digestible, most highly absorbed, and most efficient method of getting protein. Are there ways to get equal amounts of protein vegan or vegetarian diet? Yes. But if you are going to do that, you need to be very mindful of the fact that you are eating a diet where it becomes difficult to get protein, something essential for your body, and that you need to make sure that you get enough. Now, I'm going to touch on one more point, something that is usually ignored by vegans, and that's the point of deficit. It's going off of what I said before about the proteins. There are some specific things that can only be provided by meat, such as iron, which is the component of your blood that makes up your blood, folate, so and vitamin B12 as well. But in my opinion, alright, so my camera actually died there. What I was saying is that there are some things that you can only get from meat, and a couple of those things that in my opinion are important are iron, folate, zinc. So the reason why you can only get these things from meat is, well the iron and the zinc is because that's the kind of stuff that's present in your blood, right? And one, it's present in blood, and two, it's essential to make blood. And folate is also something else that is only present in meat products. And so if you do not have enough iron in your body, you actually go into a state, you have the risk of going into a state which is called iron deficiency anemia, where your body doesn't produce enough blood cells, and because of that, you don't have enough red blood cells in your blood, and you become anemic, and that's not a good state to be in. 2, folate. Folate, for adults, folate is okay if you don't have enough, but where folate becomes very, very important is when you actually start thinking about, fetal development in children, because children, so a fetus in which the mother does not get enough folate develops something called neural tube defects, where the tissue around their spinal cord does not fuse fully, and therefore they're born with their spinal cord exposed, either most commonly from the back end, but I guess sometimes it could be from the front too. Anyways, neural tube defects, spina bifida, not good. So if you do choose to follow a vegan and vegetarian diet, it's perfectly fine. At the end of the day, it's all about doing something that you enjoy and that makes you feel good. But always be mindful of these deficiencies, right? Protein deficiencies. We said protein is essential for the body. Iron deficiencies, folate deficiencies. If you can manage those 3 things, by all means eat a pure vegan diet. But like most people, we don't have the time and the energy to sit there wondering, oh, did I get enough vitamin B12 today? Oh, did I get enough folate today? Did I hit my proteins today? Alright, so that was my little rant and my little video about my take on veganism. I kind of went off track. I didn't really talk much about how it affects weightlifting, but the idea is that, if you're lifting weight, trying to get bigger muscles, that means you want to have more protein in your body than a regular human being, which means that you should technically be eating more. And because on a vegan diet, you're not already at a risk of not getting enough protein, it's not the most conducive to gaining muscle. Other than that, I hope this video was somewhat informative, not too dry, and hopefully I'll make another one. See you later. Thanks for watching.